Welcome back. So, this whole business of doing the online course is getting increasingly frustrating because I don't have the option to interact with the students to try to get some critical feedback, which I think is very important and maybe is in some sense the main point of this very short but important vignette, which is a philosophical aside. And so, what I wanted to talk about is that one of the observations that I've had about my course thus far is that if we were in the classroom over and over again, I would have called attention to key papers, and then I would have asked my TAs to actually post those papers on the course website. And if you go to previous years for this course on my RP group website, you'll see that for BE/APH 161, the reading lists are really actually quite large. And so I regret that I've done a bad job of giving credit where it's due, and I think that this is one of the most important and sacred duties we have, and actually, it's a pleasure to celebrate the achievements of others. So today I'm going to give another vignette about compartmentalization, and it's going to be a chance to show you a paper that I think highly of. But in general, what I wanted to do was to cover the subject of the literature. So the first thing I want to say is that I keep careful records of every paper that I read, and I read on the order of 150 papers per year. And a few years back, I was reviewing my end of the year, and I realized that probably out of the 150 or so papers that I had read that year, that I could have lived without 130 of them. And I felt like that really showed that I was doing a bad job of picking the papers that I was reading. And I was at a Hertz retreat with Joe Polchinski, who unfortunately is no longer with us, and he was expressing to me some of the excitement about the papers that he had read having to do with holographic universe or something. It's above my head, but it really made me, sort of revisit this idea of being a lover and not a hater. And so, I've already mentioned it in the course, this notion of experiments to change your life for. And here I wanted to give you four or five concrete examples of, great papers ultimately that made a big difference to me. And the citations will not be that accurate, but you can go take a look for yourself. So one of the first experiment that really caught my eye in biology is shown in the middle, and this is a paper from the group of Carlos Bustamante, where what they did is they measured the force buildup inside of a virus as the DNA was being packaged into the virion head by an ATP consuming molecular motor. The one at the upper right is also a signature paper for my career in, for whatever it's worth in biology. And this is a beautiful experiment done in the group of Mueller Hill, who over and over again did these really pioneering studies that I would call, signature achievements in the world of quantitative biology. Here, what they're doing is they're looking at the gene expression of a particular gene that it features DNA looping. The transcription factor binds at two sites on the DNA, and what they're doing is they're varying the distance between those two sites in single base pair increments. And I want you to realize, we're talking about a third of a nanometer change in the length of the DNA, leading to these reproducible, very large effects in gene expression. So that's really like atomic level engineering, I think, in quite a beautiful way. So that experiment, if you like, the periodicity has to do with the fact when the transcription factor binds on the DNA, if you add five more bases to the between those binding sites, it will twist the DNA around by about 180 degrees. So the DNA is no longer in registry for the binding of those two heads. And so you're basically getting a readout of the twist elasticity. On the lower right is the classic two-slit experiment, sort of made famous by, well, you could go all the way back to Thomas Young to think about it in the context of conventional waves, but made famous really by Feynman in his book on path integrals and in the Feynman lectures and in his book QED. The idea being that even a single electron or a single photon will show interference, kind of a crazy thing. That's what's shown on the bottom is an interference pattern obtained one electron at a time by a Japanese group. In the upper left is an ecological experiment that probably couldn't be done now by Simberloff and E.O. Wilson at Harvard, where they went to the Florida Everglades and they basically fumigated an island, and then they watched as the island was recolonized. Very, very important and interesting experiment, at large scale. And then the last one on my list is in the lower left, where on the lower left you see the the so-called Keeling curve, which shows you the CO2 increase. It's now dated. We're well over 400 at this point, parts per million. But in a really wonderful and sort of strange irony, his son Ralph Keeling, David Keeling's son Ralph, has undertaken the measurement of oxygen, and that's what you see in the second panel of that figure. So my point here about is about for me wanting to be complimentary of other people's work, about wanting to embrace the achievements, the cleverness of other people in this world of science. And I realize, we're programmed to be critical, and that kind of brings me to a point I'm going to make in a moment, which is, if we want to be critical, I think the best place to do it is by looking in the mirror. So I'll come back to that in a moment. A second sense in which I wanted to comment on the literature is, in a way, related to this theme of being a lover rather than hater. It has to do with repurposing the notion of a journal club. I in some ways, it's probably not a popular opinion, but I don't know. I've been a professor for a while. I've tried to think this through. I think this whole thing about learning to read papers critically and having these courses in which you read papers and you shred them, I don't find that particularly compelling. I find it to be a bit like shooting fish in the barrel. You can always find something wrong with other people and their work. I mean, again, look in the mirror. There's so many ways that we fall short, and so I think that's easy, to be critical. I think much more interesting would be to say, well, in part B of this figure, what they're doing, this is this wonderful paper by Heinemann, which indeed I have some critical remarks about because of the accuracy that's reported in their spreadsheets and because of the weirdness in the which I showed you earlier, having to do with the membrane proteins and their counts. Fine, whatever. It's still a path-breaking study that I think is amazing. And, I built a whole few years of my group's effort around trying to better understand this beautiful set of experiments. But yeah, we could be critical if we want. But, for me, Journal Club is really about, look at part B. Here's your assignment for those of you listening. Justify the units on the y-axis. Make an argument. Go to your desert island, sit there and talk to Wilson, and tell me why 100 femtograms is the right scale on that axis, why that makes sense. To me, that's what Journal Club is about. It's about meeting the authors halfway. It's about taking their work and understanding it, trying to understand what they did, rather than in 2 hours saying, oh, I know more about your thing and all your fatal flaws than you know after 2 years. So that brings me to this point about another point about the literature, which is the deep inspiration that I've taken from chapter 6 of Darwin's book, which is called Difficulties on Theory. And in it, what Darwin did was he tried to pick apart his own work. It's a beautiful thing. It's a really, really nice thing, and it's easy to do. If you when we're writing our own papers, at the end of every paper, it's so easy to find ways to say, if I had more time, if I had more money, if I'd had more students, if I'd had more smarts, here's what we would have done differently than we had done. But I think that's just it's a model to hold up as to what the critical feedback process is like. Sure, I'm all for getting critical feedback from our colleagues, and I think it's important, and I'm a fan, but I think no one should be more critical than we are of ourselves, and then I think a wonderful thing you find at the tail end of Newton's book on optics was he had these queries, and this is just to come back to my usual theme about I wonder, in some ways, in thinking about the literature, I think a nice way to end the reading of somebody's paper is with some I wonders. I wonder X, I wonder Y, I wonder what this implies about this or that phenomenon, or can I come up with a model that makes a polarizing prediction, that kind of thing. So this whole thing was just to, first of all, offer an apology to the listeners for my poor job of keeping up with the citations that should be on my slides. It's not meant to take anything away from the work that I'm reporting. And if you're curious to hear where a particular thing came from and I didn't cite it, A, apologies to the authors, and B, please email me and I will do my best to try and reconstruct for you where things came from. I think my last point is this is at the ESPCI in Paris, which is where De Gennes was was the head of the entire laboratory. It's a really cool place. The Curies were there as well. And I've always liked this quote that's on the wall. It says, "True science teaches above all to doubt." And so, to me, with respect to this question in the literature, I think sort of embracing with a spirit of generosity and equanimity the work of others. Yeah, I want to doubt, I want to question, but without being mean spirited or demeaning to other people's hard work. So anyway, that was a brief aside. Primarily driven by the desire to call myself out for not doing a better job with